My name is Dominic. My partner and I, Omid Ghomeshi, are doing a presentation on universal and existential instantiation. The basic concept of universal quantifiers is that, given the statement for all x, p of x, we can infer that p of x is true for all x. The ax that you saw preceding the statement is what is known as a universal quantifier. The basic concept of existential quantifiers is similar. If you have the statement there exists an x for which p of x is true, then you can infer that p of x is true for at least one x. Again, the e you saw preceding statement is what is known as an existential quantifier. Universal instantiation is a rule of inference that allows us to take the statement for all x, p of x, and infer from it that the statement p of c is true, so long as c is in the domain of x. Here's an example of universal instantiation. If we have the statement c of x, which is x has taken discrete math, and the domain of x is all computer science students, and c is in the domain of x, then the statement for all x, c of x, implies that c of c is true for some c in the domain of x. Existential instantiation is another rule of inference that allows us to take the statement there exists an x for which p of x is true and infer that p of a is true for some a in the domain of x. This can be one or more a's, but we know it is at least one. Here's an example of existential instantiation. Statement p of x is x received an A in physics. So if there exists an x for which p of x is true, we can infer that p of b is true, and so b received an A in physics. In most cases, we won't know what the specific b is, just that it does exist. Here's how to apply the above concepts to a proof. Show that if there is a student who is in discrete math who has not taken EECS 280, and everyone who is in discrete math is a computer scientist, then there is a computer scientist who has not taken EECS 280. The statement d of x is x is taking discrete math. The statement p of x is x has taken EECS 280. And the statement c of x is x is a computer scientist. Our first step is to write down a symbological logic version of our first premise. There exists an x for which d of x and not p of x. Using existential instantiation, we can then infer that for some a in the domain, d of a and not p of a. Remember that we don't know what this a is specifically, just that it does exist. Simplifying the above, we know that d of a must be true. Our second premise, written in symbological logic version, for all x, d of x implies c of x. Using universal instantiation, we can now infer that for any a in the domain of x, d of a implies c of a. The above then means that c of a must be true. That is from Monis Ponens, by the way. So then, we can take another simplification of step 2 up above and say that not p of a must also be true. Given the above two steps, we know that c of a and not p of a are true. And so therefore there exists an x for which c of x and not p of x are true, meaning that there is a computer scientist who has not taken EECS 280. Again, remember that this doesn't prove what that specific computer scientist is. All we've proven is that this computer scientist exists.